Hi everyone, today we're going to look at classification, a very common data analytics task. Specifically, we're going to look at the important ingredients of classification, such as the data, the model, and how to penalize mistakes. So we'll start with the common setup of a classification problem. So suppose we want to look at whether someone would like a song or not. So as in this table, where the first column is a song name, and the right-hand column is the label. So whether I would like it, not like it, or maybe neutral. So this is a very simple, but also the very standard way how classification problem is set up. So on the left is what we call the feature or characteristics about the data. And then on the right-hand side, so that's the labels. That means that's what you care about. So the question is, how do we determine the label for something we have never seen, such as the very last song here, Chopin number 5. So will we like it or not, based on what we know about a particular user? So in any classification problem, there are 3 important ingredients. So the very first one is data. So data, often we get the notation of S, which consists of 2 parts. The first part is X, and then the other is Y. So X is we call usually the attributes of the data. And usually we use a notation of D to signify how many attributes there are. And Y is the label that you care about. So in previous example, that is the sentiment label of whether I would like or not like a song. And often we use a subscript I to specify which data instance we are looking at. And also a small n to specify the number of data points. So in a classification problem, we also need something called a model. So we'll go into more detail about what we mean by model. But loosely, you can think of it as some way of mapping the data that you have, which is X, into the label that we care about, which is Y. And there are many different ways to figure out this mapping. And often this kind of mapping, you can think of it as having some kind of knobs that you can tune or you can change. And this is what we call parameters. And here we say we may have parameters A, B, C, and so on. And you can have very few parameters, which often is actually a good sign. So that means there are not that many of these knobs that I need to tune or to figure out the exact values. Or sometimes you may have a lot of these parameters that you might need to tune. And it can take a long time to do that. And the third important ingredient of a classification problem is the loss function. So often, this may not be discussed as much, but it's actually very important. So the loss function is the way for you to determine how to penalize mistakes. Because when you create a model, the model is never perfect. So that means the mapping not necessarily perfect, or may be able to help you to determine labels of unseen data perfectly. So you need to know how to penalize these mistakes so you can know how to tune the knobs towards a better numbers or values that can give you a better model. So more concretely here, we're going to explain what data is, and also what model and loss function. So I'll start with data here. So using an extension of the example that we've seen before, here at the bottom, we have extended the data to also include the artist name and the length of the song. So now more clearly, you can see that the attribute could be the song name, it could be the artist name, it could be the song length. And the label here is the same. So that means whether I like it, I don't like it, or neutral. So I need to note here about the terminology. So in machine learning, often we use different names to mean the same thing. For example, data example and other name, we call it would be data instance. And similarly, for attribute, other names will include feature, dimension, characteristics. And for label, sometimes people also call them target attribute or class. So what is a model? So we mentioned that in machine learning or for classification, it's important that we create a model or a mapping. So at a very high level, a model, you can think of it as a simplified representation of reality. So this is actually a definition from Data Science for Business. So everyday example include maps which we probably use every day. So map is also a model because it's an abstraction of our physical world. And as you may guess, there are actually many kinds of models. So imagine when you are driving, you might want the map that benefits you to help give you direction. But sometimes if you want to know the terrain of a city, then you may want to use a satellite view. So that means there are many models, and which one works better depends on your task. So similarly, for a classification problem, you can also have different models. So sometimes one model works better, and sometimes another model works better. And more concretely, you can think of the model as a formula to estimate what you care about. And this formula can come in a variety of different formats. It can be mathematical, let's say just one formula, or it could be rule-based. So that means you can have a lot of rules, or maybe even a combination, some formula, some rules, and so on. So the model needs to be trained or built. And this is a terminology that you hear a lot. So training a classifier, what people means is to build a model. And when we say training a classifier, what that means is that we need to determine the knobs or the parameters in the model. So again, you may remember there could be very few parameters, which may be a good thing, or maybe it requires a lot of parameters, then you may need to spend a little bit more time to figure out all these values. So an analogy to training a model is to determine which map in the real world is a good abstraction. So previously, we looked at data and also model. So the last piece of a classification problem is the loss function. As you may remember, the loss function is a way to penalize mistakes so that you know how to evaluate the model. The most common loss function is the 0-1 loss function. So the full mathematical formula is here as shown on the screen. It may look a little scary, but all it does is actually pretty simple. So specifically, we're using identity function here, I, and it tries to look at the label y and whether it matches the predicted label f of x. X is our data, f is our model. So essentially, it's just checking if the predicted value or predicted model is the same as the true label, then we'll give a 0. If they do not match, then we give a 1. So there's a drawback of 0-1 loss function, which is that it looks at all different kinds of mistakes as the same. But as you can imagine, even in real life, for example, that not all mistakes are the same. Some are more costly. For example, if we are not able to catch cancer, then that's a huge cost. So we want to assign a bigger loss value to that. In this video, we look at classification, specifically the important ingredients such as data, model, and also the loss function.